All right, welcome everybody. Going to give folks a few moments to join. Then we'll do a quick introduction, give you guys some resources for after today's event if you're interested in learning some more. And then we'll go ahead and get started with today's presentation on magnesium oxide panels. Today's presentation is presented by Jeff with Malbastone. Really excited to be bringing you guys this new and innovative solution that he's going to share some more with us today. Before we jump into that, I am going to give y'all a few resources for after today's webinar if you're interested in learning some more about MGO panels and finding some additional product resources. You can head over to app.acelabusa.com. We'll also send over a link to this in the chat momentarily so that you can just grab it from there for after the event. Today, just going to show you one thing, but we've got a bunch of free tools and resources here. So if you're interested in learning some more, you can always use this live chat, get in touch with our team, schedule some time to do a more full demonstration. Today, just want to show you where to head if you want to get some more information about Malbastone. You can head over to the search bar at the top. Just go and type in the name of any product, any manufacturer. It'll cross-search between all of the resources we've got. And then you can head over to the Malbastone page on Acelab. From here, you can reach out with any questions. You can scroll down and learn some more about the company. And you can also access products and product information. You can save any of these to your firm library, your research folders, or your projects so that you can come back to it afterwards. And you can open up any of these product pages to view some more information, access some downloads, as well as save and compare this with other products. So this is a great place to come and get some additional resources after today's webinar. And we'll send over some links in the chat so that y'all can just jump right there easily. Last thing I want to mention is please feel free to ask any questions throughout today's presentation. You can do that using the Q&A. We'll keep our eye on that. So if anything super urgent comes up, we will get to that. And then we should have some time to answer questions live. If we don't get to your question live, we'll have a record of it and we can follow up with you after today's event. All right. That's it for me for now, Jeff. Whenever you're ready, feel free to go ahead and take it away.
Okay, thanks, Bo. So can you guys see my screen?
Yep, looks great.
Okay, cool. So we're here today to talk about magnesium oxide panels, MGO panels. I assume if you're here, you probably know what that is or have a sense of what that is already. But if not, I think a more descriptive name that we use is low carbon, non-combustible structural sheathing. So first, I just wanted to introduce myself. That's me. I'm the CEO of Malbastone. Um, I'm originally born and raised outside of Chicago, and I went to school for engineering at Illinois and Rutgers University. Um, After college, I went back to Chicago and worked for a few years as an engineer. And at that time, my manager asked me if I wanted to take a project in China to source materials. I knew nothing about sourcing or China, but I took a leap of faith and said yes. I also didn't know you weren't allowed to say no to the suits, that you were allowed to say no to the suits. So I actually ended up moving to China. At the time, China was going through a huge building boom, and the sourcing project actually completely changed, and we actually got a GC license and started building building materials for that boom. Even to today, that factory still makes 90% products for the China market. And based on that, I started what the company wanted me to lead expansion to other areas, including Europe and India. And I eventually came back to the US here in Seattle, but oversaw multiple operations and plants across the United States. So basically, that's the short version of how I became a suit at a Fortune 500 company. It was an incredible experience for me and my family. If you're not familiar, UFP Industries is one of the largest manufacturers of building components in the world. It's a great company, and the only reason I left last year to start Malbastone is because I believe MGO is about to become the next big thing in building materials. So here's a rundown of the topics we will cover today. And we'll start with a brief history of MGO. So if it gets too dry, just send me an emoji for the I'm about to take a nap feeling, and I'll try to go faster. So I'm starting really long time ago with the formation of the Earth's crust. So magnesium is the eighth most abundant element in the Earth's crust. It's really everywhere, including in the oceans. Fast forward to about 2,000 years ago, and there's been traces of magnesium-based mortars found in the Great Wall of China. But 2,000 years ago, they were really just digging anything they could find out of the earth and pushing it together to make a wall. So you couldn't consider it a building material of what it is today. Fast forward a few hundred years, and Joseph Black wrote the New York Times bestseller, Experiments upon Magnesia Alba, Quicklime, and some other alkaline substances. So you got to give him some credit. At this point, people are not really sure how air works, but he's lighting things on fire to see what would happen. And what he found was that heated magnesium carbonate becomes highly reactive. By the way, this is the same guy who discovered carbon dioxide. Fast forward another 100 years, and the first major application is invented for magnesium oxide as cement. This was known as Sorel cement after the founder. And he found that magnesium oxychloride cements have really high compressive strength and impact resistance. And one of the big applications at the time was to make billiard balls. So fast forward to what I would consider the real genesis of this industry, which happened in China from probably about 1990 to the early 2010s. So if you look at that picture on the right, that's the skyline of Shanghai in 1990 versus 2010. So it's really hard to quantify China's building boom, but from my perspective, a significant proportion of like the entire human population went from 0-story buildings to high rises in about 20 years. So during this time, there's a huge need for fire-rated materials. So MGO found a niche as a substrate for interior decorative surfaces, and that continues to this day. So imagine people laminating melamines or different fabrics, anything onto a prefabricated decorative panel. The fire code requires it to be non-combustible, so magnesium oxide was really the perfect solution. So about in the early 2010s, people started traveling to China and seeing the potential of this material and started using it in different applications in the Western world, which we have a lot of stick building here, and in China there's really no stick framing. It's all concrete. 30 stories is considered a low rise there. So some of you might have heard about the issues in Denmark, and what happened there was they were taking what was designed for an interior use and using it as an exterior facade. So there's some moisture issues that you can read about on Google. But if you look at the composition of those panels, there's a very high wood fiber content, and there is also a component of magnesium chloride, which could cause some corrosion issues. But there's, on the other hand of that, there's also tons of magnesium chloride boards that are still in use today in interior applications that have no issues. So that leads to the kind of the latest generation, which I think is what's driving the expansion of this magnesium oxide today, is that the latest boards actually have eliminated most of the wood, most or all of the wood component, and also the chloride content. So these are called magnesium sulfate boards. So the main salt used in the reaction is Epsom salt, the same salt you can buy at Walgreens. And by reducing the wood content, it is much more moisture resistant. So that even you can see a lot of applications now, there's products in the market today that are used as moisture under wet conditions such as tile backers, and also even in exterior applications now. So if you look at even the new Disneyland in Shanghai, as well as Universal Studios in Osaka in Japan, magnesium oxide is used widely as an exterior surface to replace the precast concrete. So next we'll go into some of the features and benefits. So the way I would look at it is, I think the easiest way to describe it is that magnesium oxide offers the properties, the non-combustible properties of a lot of gypsum-based products that are also fiber reinforced. So think Type X wallboards or gypcrete. And then it also offers the strength of engineered wood in a single material. So this will allow you to combine multiple materials in different assemblies. It also has good sound control properties, especially for floor and wall assemblies. And it can be installed with existing tools used in wood framing. So it's at about 80 pounds a sheet. You're talking something that's it's heavier than plywood, but it's considerably lighter than the other precast concrete panels and boards that are available today. The other application, the other killer property is that it can be considered low carbon, especially compared to Portland cement-based products. So, and that today is not a big issue, but we can see in jurisdictions such as California that are already starting to track and mandate a reduction in embodied carbon into building materials for certain size buildings. And I believe for multifamily, that's any building over 5 units. For the application I just talked about with Gypcrete, you're actually replacing a wet trade. So this could offer substantial savings in both cost and time for your construction. And it's also, replacing some of the issues like introducing moisture to the building. And lastly here, because of these benefits, there's significant potential cost savings. So taking a little deeper dive into the climate impact potential, the reason why magnesium oxide can be considered much more lower carbon impact than Portland cement-based products is because it's using half the energy during the production time, especially in the creation when fabricating the raw materials. The second part is that magnesium has some special advanced carbon mineralization properties so that up to 20% of the weight of the final product can be from absorbed atmospheric CO2. It's also curing at an ambient temperature, so it's actually absorbing carbon dioxide during that time where it's curing in the factory. There's also scientists currently working on making this a potential carbon neutral product by using zero carbon energy sources to extract the raw material from sources such as seawater. Okay, so this is probably the meat and potatoes of what people today here are interested in. So I want to go through some of the applications of magnesium oxide and the potential benefits and things to watch out for. So the first application would be to replace gypcrete underlayment, especially in multifamily wood frame construction. So basically you could have the same fire and sound properties as a gypcrete assembly, but you're basically eliminating all the mess of a wet trade. You have no stoppage of work as the magnesium oxide panels can go in during construction as the floors go up before your walls are set. There's no introduction of moisture. And by eliminating this wet trade and the potential curing process, which can vary depending on where you are in the country and what's happening outside, you're eliminating a big schedule risk. The one thing that gypcrete does have that magnesium oxide doesn't have is the self-leveling properties. So, I think a lot of people, I've been to a lot of job sites where people are using gypcrete to cover up holes they made to run their speaker cords to play their music. But so there's some care that needs to be taken for that, but those aren't insurmountable. And anyways, even gypcrete self-leveling properties in certain cases creates more problems on its own too. Okay, the other application here is for looking at wall assemblies. So when you have these fire-rated wall assemblies, a lot of times you're using a gypsum-based product, which could be brittle and also not hold your cladding. So you still have to find the studs when you're attaching your cladding. So what magnesium oxide can do is have both the properties of the, say, dense glass and also the structural strength of the substrate plywood or OSB. So some other products you can consider is like you probably might be familiar with LP flame block. That actually is magnesium oxide too, laminated onto an OSB substrate. Due to the strength properties of magnesium oxide, there's also shear wall applications too. Um, the next application looking at, and this is, you see this a lot in type 1 and type 2 constructions, um, where you use product, maybe like product like Structocrete, which is Structocrete is a precast board, Portland cement based concrete board, and it's replacing the metal pan and poured concrete. But you can replace both of that with magnesium oxide, which is significantly lighter and cheaper. Another application is in modular and volumetric construction. Um, so one thing, I don't know if many of you are familiar with, but during COVID, you probably saw in Asia that these prefab volumetric hospitals, the ones that are allegedly going up in 7 days, and some of them were 10 stories tall, some of them were sizes of multiple football fields. Those are almost all made with magnesium oxide boards. I don't know where they all went today, but they made a lot of them at the time. And then another application that we're currently exploring, especially as it's this mass timber is gaining momentum, especially out here in the Pacific Northwest, is to look at fire and sound applications within mass timber. So right now there's still a lot of gypcrete and many layers of fire-rated gypsum used across mass timber, so that we believe that the non-combustible properties of magnesium oxide can also have a big application as this segment grows. So the next thing I want to talk about is, as with an emerging technology like magnesium oxide, what kind of standards and certifications, as I'm specifying, is how do I know I'm using a good product? So the way I've counted that is that based on the history part we just talked about, it's actually not that new, and it's widely used in many parts of the world in different applications. But so what I'm talking about today is specifically for the United States. So the first thing is the ICCES has already released an acceptance criteria for magnesium oxide panels, and it's called AC386. They actually just updated it last October. And this is probably the most comprehensive set of test standards for magnesium oxide panels today. It includes on-site quality audits. It goes from testing, ASTM testing for strength and loads, and specific things for magnesium oxide, such as moisture, fastener holding, and even corrosion effects. Since almost all of the magnesium oxide is still produced in China, some people are concerned about the supply chain. Well, we've chosen to partner with Intertek, which is one of the largest quality assurance firms in the world, with boots on the ground everywhere, basically everywhere in the world. So they've been issuing code compliance research reports, and they also have a directory, a building products directory that's accessible online that you can see, and it goes deep into the details of the quality process, which we can discuss afterwards in the Q&A too. This next section I really put in here just because it's really cool to have photos of fire here. But this is really one of the best properties of magnesium oxide. And if you look at it, so it's magnesium oxide's other use is actually as a refractory material. So you'll see it a lot lining the furnaces of steel plants, and even the crucibles that are made pouring steels that you see in Terminator. I mean, a lot of those are magnesium oxide as well. So here's a different ASTM test standards. So E119 is the test standard for assemblies. So that would be for floor assemblies, wall assemblies, and that's what you typically see the 1 hour, 2 hour, 3 hour ratings. ASTM E84 talks about flame spread, and those are both required. Both of these tests are requirements for AC386. And then the last one here is this is for a differentiator for different products, is ASTM E136, which defines combustibility. So this is where there's some difference between the panels in the market today, and a lot of it has to do with the wood fiber content in it. So some, like our product, has basically eliminated all the organic material, so we're able to achieve an E136 non-combustible. So it could be used in type 1 and type 2 construction as well. But you'll see a lot of magnesium oxide, especially the chloride panels, that still have some wood fiber content in them. So they wouldn't be able to pass this test, but they'd be appropriate for uses in type 3, 4, 5 construction. And then if we get into some of the science part of this, if you were interested, we could go on this forever too. But the main difference to think about this is just how the crystalline formation of the cement itself is what gives it a lot of its properties. So today, it's actually not so hard to do X-ray diffraction on materials, and you can look at the different phases of the concrete itself, of the cement, magnesium cement itself in the board. So I guess if you're interested, reach out to me and talk about it. But for magnesium sulfate, what you're really looking for is the 517 phase. And for magnesium chloride boards, you're looking for the 318 phase. And that's what gives magnesium oxide the properties it has. Okay, and lastly, this is a little bit about more of the company, our company Malbastone, and who we're partnered with. We're currently in the Impel program, which is part of the U.S. Department of Energy, and it's really focused on decarbonizing buildings. So everything from energy efficiency. Our cohort has companies that are doing triple pane windows and photovoltaic cells, but also many that are the Department of Energy has invested heavily into reducing the carbon footprint of buildings and the materials that we use in buildings. We're also part of the Clean Tech Alliance here in Seattle. And then, as I mentioned, our partner organizations that we're contracted with both ICC evaluation service and also Intertech quality assurance. So I guess I went a lot faster than I thought, so that's kind of the end of my presentation here. But my ask for you guys before we go into the Q&A would be really just we're looking to speak with innovative developers, architects, and contractors who want to improve their bottom lines and reduce their environmental impact. So I look forward to hearing from you guys, and I think we just open it for questions now.
Awesome. That sounds great. Yeah, if anybody's got a question, reminder, you can use the Q&A to do that. You can also raise your hand if you've got a question that feels, a little bit longer-winded. If you want to ask something out loud, you don't have to turn your camera on. So I promise it's not super scary, but that can be a great way to ask a question if you feel like typing it out feels too long. All right, looks like, what are your incoming wire instructions?
Oh,
Our
like
first
my
one.
checking account?
Thank
Fell for
you.
that one before. Please reach out. I mean,
To
do
make
you?
an investment, says Dan. All right, well, definitely maybe chat with Dan after today's event. All right. I also saw somebody had asked if they would be able to get a copy of the slides. Is that something that you would be willing to share?
Yeah, absolutely.
Awesome.
Yeah, so just feel free to, and that's my cell phone on there too. So feel free to reach out or send me an email. Be happy to chat.
Great. Awesome. And then while we're waiting to see if any other questions come in, I will just recap some information that we covered at the top. So one moment here. Also a reminder to everyone to grab this link from the chat if you need it, but I'll show y'all again real quick how to find Malbastone on Acelab if you're looking for some more information after today's webinar. So I'm going to steal back screen share for just a moment, Jeff.
Oh, okay.
Oh, there we go. All right, great. So in case you joined us a little bit later and missed this at the top, I just want to show everyone where you can access some more information about the products that we covered today, as well as get in touch with Jeff and explore some more about Malbastone. So everyone has a free Acelab account. You can head to app.acelabusa.com, explore a bunch of the free resources that we've got. If you need to get in touch with our team with any questions, you can use this live chat in the bottom here. Book some time with someone to do a quick demo that will be more than what I'll show you today. But today, just want to show you what to do if you know exactly the product or the manufacturer that you're looking for. You can use this search bar at the top, type in the name of any product, any brand. Make sure you toggle through to cross-check all the different categories that we've got. You can head over to the Malbastone page on Acelab. From here, you can scroll down to view some more about the company, and you can explore their products as well. What's really great about this is you can save these to your firm library on Acelab or to your research or just to a project directly, and then you can come back to this product information anytime. You can also open up any of these products to view, some more information, to access downloads, and to save them to comparison tables so that you can really easily compare this to other products as well. So this is a great place to come for some more information after today's webinar. Grab some product downloads if you're interested in storing some of that in your library. All right. And that link is in the chat for anybody who needs it. So feel free to grab that from there. You can head to that page directly. Cool. And we've also got some folks who are asking about a recording for the webinar. So I'll send over a link to where you can access webinar recordings on Acelab. We post all of our recordings to that link, usually a day or so before that gets uploaded. You'll also get a link to that in a thank you email as well. All right. Let's see, we've got a question about the CO2 absorption. Looks like somebody's just wondering for some more details about the CO2 absorption claims, specifically how 20% weight from absorbed atmospheric CO2 is achieved and then verified.
Yeah, so there's a lot. So I mean, I'll be very honest with you. I mean, this is not a completely finalized um, process because, and a lot of it very dependent on ambient conditions, even the seasonality. But you can find a lot of
Mhm.
research, especially the University of Toronto Cement Department has done a lot of published papers about the chemical formulas proving that it is absorbing CO2.
Mhm. Awesome. All right, and we've got one on lead times. Are there different lead times for different panel sizes, and do you maintain a certain amount of stock?
So yes, but at this size right now, it's it would be probably more appropriate to discuss your particular project offline, um, especially for multifamily projects where you have a larger volume. A typical lead time is probably right now 6 to 8 weeks.
Mhm. All right. Do you have mud, tape, paint, or best practices available for your boards and install best practices?
Yes. So the short answer is yes. And we have done a lot of studies on different applications for interior walls. So interior walls is, if you think about it, that as I mentioned in the presentation, that's the largest application within China. So they've used different types of muds and mud and tape, but even just a lot of testing was done on just the same way you do gypsum wallboard. Um, Same thing for floors. So we've been testing on different floor finishes too, especially like some of the thinner vinyls that we see a lot in multifamily today, to
Mhm.
make sure that there's no um, you don't see any of the subfloor translating through the floor finish.
Right. Do you have any hypothetical illustrations of the projected savings on different scale developments, i.e. residential, commercial, or industrial?
So yes, and I think there's just some averages that we kind of look at, especially when you're replacing gypcrete. So just from a pure cost standpoint, we're seeing a 30 to 40% reduction. But as some people know, especially if you were here last year, where a lot of the gypsum comes from Canada, and when the rail went out, there was a huge shortage last year of gypcrete, and the prices went through the roof, and you couldn't even find people to do it. That
Mhm.
also happened during COVID across the whole country, and I understand a lot of people are flying from city to city for these kind of gypcrete jobs.
Mhm. Can you talk more about the sound deadening qualities?
Yeah, I think that's an important thing, and there's even more research going on into this to even improve past what gypcrete does. But
Mhm.
our tests on just a typical wood frame floor assembly, where we're looking at like I-joist or open web trusses, and a OSB subfloor, that we can still get into STC and IAC in the mid 50s, which is typical to all these different what you see with gypcrete and Acoustamat. Um, There's certain applications where that we've been researching from uses in China that they've also looked at sound and varying the different densities within magnesium oxide panels to get even higher sound deadening qualities.
What are some projects using these panels or products that we could see online?
Um, so so I'm going to be very honest. I'm not the only person that thinks that MGO is going to be one of the next big things. So if you just Google
Mhm,
MGO, you can see a lot of projects probably within your neighborhood.
mhm,
And if you haven't heard about it yet, I believe you will soon. It's either you can reach out or someone's going to knock on your door soon enough. That
mhm.
person might be me.
All right, let's see. When this has been used as structural sheathing, whether it be in floor diagrams or shear walls, diaphragms or shear walls, has this product been applied on top of structural sheathing, or has it provided the structural rigidity itself? And has there been a type of shear wall at which this product does not provide enough rigidity, such as your highest capacity shear walls?
Okay, I'll talk first about the floor application. So our product, right now what we're selling that we have certified that I mentioned in the presentation is a 1/2 inch by 4 by 8, and that's still the use case would be on top of engineered wood subfloor. But we are in development of a 3/4 inch product that will go through the E455 diaphragm load testing that
Mhm,
could replace both layers of the engineered wood subfloor and the gypsum underlayment. Um, for for shear walls, we have we've seen allowable loads over 300, 350. So I guess for a specific case, we'd probably have to take that offline and discuss it individually.
mhm. All right, let's see. This might be our last one for now. So if you have any further questions, now would be a good time to submit it. But let's see here. Which Malbastone product do you recommend for floor sheathing to replace plywood subfloors?
So that's like I just mentioned, it's still under development, but we'll be coming out with a 3/4 inch product. Hopefully, it's going through certification now, and hopefully by Q2 that we'll have that available. But right now, the one that we have finished is a 1/2 inch that can replace the gypsum underlayment.
Got it. All right, awesome. Well, it looks like that might have wrapped up all of our questions for now. So if anybody has questions that are coming up as you're leaving today's webinar, feel free to use the post-event survey as a place to leave those and any other feedback that you might have. We would really appreciate if you could take just a moment to fill that out as you're heading out from today's webinar. You can also grab that link from the chat to head to the Malbastone page on Acelab. You can reach out there with any questions as well, and access some product information that might help you in your research. Other than that, just want to thank everyone in the audience for coming out today, for asking so many really great questions. Really appreciate the engagement and the interest in learning some more about a really new, exciting product. Jeff, thank you so much for joining us today.
Thanks for having me.
All right, have a good rest of your Thursday, everybody.